In this section, we are going to discuss ES6 class syntax, which is one of the important features added to the JavaScript language. This new ES6 class syntax simplifies the way we deal with creation of objects and prototypal inheritance. I have my intro app open here in my automate editor. Firstly, I am going to comment whatever I have in my index.js file so that I can directly demonstrate the usage of ES6 class by writing the code over here. Let's put some random log to make sure our code runs on the browser. I'm going to keep the log of hello world. Let's save it. Make sure your build server is running fine and turn out to our browser. And we can see the hello world log displayed on the browser console. Okay. Let's remove our log for now. Okay. To start with, I could say all the ES6 features can be categorized into two categories. First category is the new conceptual additions to the JavaScript language like promises, generators, etc. And the other category is the features that are just syntactic sugar over already existing ones to make their usage a bit cleaner and simpler. Syntactic sugar just means that there is a new syntax or different syntax to do something, but it still works the same way under the hood. This ES6 class feature falls into the second category of syntactic sugar. It means it doesn't introduce any new stuff to the language as such, but provides a kind of simpler, alternate syntactical way to create objects and to deal with inheritance. Inheritance, I mean prototypal inheritance in JavaScript. One of the tricky parts of JavaScript, especially for beginners or programmers from other programming languages, is understanding and deal with prototypal inheritance, because it's not the same inheritance mechanism that's been adopted in other programming languages like C# and Java. Under the hood, whenever we use classes or extend classes to inherit properties and methods, we are still making use of the same traditional prototype and prototypal inheritance itself. If you have little or no idea of what I am talking about, don't sweat it out. We'll discuss more on prototypal inheritance and ES6 class syntax at great length. At first, we'll see how we traditionally used to create an object using function constructor syntax and then how it can be done using ES6 class syntax. We can see how neatly it helps us to organize our code in the ES6 class-based approach. Alright, let's start writing some example. First thing that we need to do is to create a function constructor by name employee, which is like a blueprint for all the subsequent employee objects created from it. Function constructors are just normal functions that are used to create an object with the properties defined inside its body, and finally return that newly constructed object when they get invoked with new operator. Let's define an employee function constructor. I'm going to define it using function expression syntax like this. And as usual, by convention, we keep the first letter of our function constructor name as capital to distinguish them from regular functions. And if we want, we could have even defined it using function declaration style like this. Both the ways just works fine. For now, I'm just going to stick to my function expression syntax. Okay, let's pass some arguments to our employee function constructor. So I'm going to pass the arguments first name and last name to it. And let's define some properties inside our employee function constructor. So I'm going to define a property by name first name and assign it to the argument first name. And similarly, I'm going to define the property last name and assign it to last name argument. It should be taught over here. Okay, now that we have implemented it, let's use it to create an object. So I'll go ahead and create an object of our employee function constructor using the new operator. So I'm going to declare a variable by name Sam, and I'm going to invoke new on our employee function constructor with the appropriate arguments passed to it. So I'm going to pass the first name as Sam and last name as Williams. Okay. To explain in brief what's going on in this statement is, firstly, new creates an empty object and makes this inside employee points to the newly created object, then invokes employee. Since this now refers to the brand new object, all the properties that are being created inside function's body are attached to this new object now. Like first name, last name are all properties on our new object. When it's done, the whole new object is assigned to the variable on the left hand side of assignment, which is in our case Sam. So Sam is our object created with employee function constructor properties. You can think of it as if there is an implicit return this at the end of our function constructor body like this, when it gets invoked with new operator, which facilitates our new operator to initialize the properties defined inside its constructor's body on the new object before assigning it to the variable what it's been assigned to on the left hand side over here. Okay, so let's go ahead and log Sam object to see what we get on the browser console. Okay, let's save it and head over to our browser. And sure enough, we get to see Sam is an object that contains properties defined inside its employee function constructor. Okay. Now that we have added some data properties, let's add a method to our employee function constructor such that it will be accessible to all the objects created from it. I can add a method or any subsequent methods directly to this. They're inside our function constructor's body itself. Like suppose getFullName is my method name. So I'm gonna add getFullName, which is a method like this. But we shouldn't be doing like this in most of the cases, because whatever we specify inside function constructor's body prepended with this dot will be added as a property on every object created from the function constructor. But we want to share the methods across objects rather than creating them every time whenever we create a new object. We want to keep data of each object as unique, but methods operating on those data should be created only once. So to share the same methods across multiple objects, we add methods to the special property of function constructor called prototype. Prototype is just an object available by default on every JavaScript function. Say if I create 1000 objects of the employee function constructor, each one of those objects will still refer to the same prototype object. Okay, let's add a method getFullName on our employee prototype object like this. Employee.prototype.getFullName, which is a function, and as the name indicates, it's gonna return with a combination of the first name and last name. Like this. Okay, now we can call getFullName method on objects created from employee, and whenever we call this function we get the full name of the employee. Let's log the method call now. So I'm gonna call getFullName method over SAM object, which has been created from employee function constructor. Okay, let's save it, head out to our browser, and there it is. We get to see the full name of our SAM object, which is Sam Williams. Okay. Every object gets their own data members with the values assigned to them at the time of their creation. But all the created objects share a common reference to the methods added on their function's prototype. Methods in prototype of our function constructor gets attached to the __ proto for the objects created from it. So we can get to see our getFullName method defined on employee's prototype is available over here on our SAM object through its __ proto property. So all the objects created from the function constructor using new will have a reference to the function's prototype through which it can access the methods defined on it. Okay, to sum it up, we first defined a function constructor where we can declare some properties or data members. And every object instantiated from this function constructor gets these properties initialized inside them as per the arguments provided. And then if we need to add some shared properties across all its created objects, then we'll append them to a special property object available on every function by default, which is prototype. Okay, one quick note before we wrap it up. Make sure you always invoke your function constructor with new operator, so that the created object will have the properties of function constructor inside it along with access to the properties defined on its prototype through its __ proto property. Okay. That's about the function constructor and its prototype. In the next section, we'll discuss about how we replicate the same using ES6 class syntax.